Alkenes are a group of unsaturated hydrocarbons that contain double bond between carbons. To have double bond between carbons, there must be at least two carbons. So the smallest alkene, ethene, contains two carbons. Notice that each carbon still has four bonds. This carbon has 1, 2, 3, 4 bonds. This carbon also has 4 bonds. 1, 2, 3, 4. Because these two carbons are holding on each other, they have less free electrons to bind to hydrogens, and each carbon here has only two hydrogens bound to it. Here is another alkene, propene. This is a double bond between these two carbons, which limits how many hydrogens can be bound to these carbons. And yet, each carbon in this molecule has four bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You already know that the number of carbons defines the number of hydrogens present in the hydrocarbon. Considering that in the alkenes, two atoms of carbon will be holding on one another, the number of hydrogen bound to the carbons will be less than what we see in alkanes, but still very much predictable. Alkenes have their own general formula. So, the number of hydrogen atoms in the molecule will always be twice the amount of carbons that forms that molecule. Here is ethene, 2 carbons, 4 hydrogens. Propene, 3 carbons, 6 hydrogens. Butene, 4 carbons, 8 hydrogens. The name once again tells us all about this compound. Prefix tells us the amount of carbons in the molecule, and the ending "-in" tells us that there is a double bond between carbons in its structure. Let's name this alkene that has 5 carbons in it. Pent, prefix that indicates 5 carbons, and the ending "-in" that tells us that there is a double bond in it, pentene. Okay, over here hexene, heptene, and so on. Here I want to remind you that the structural formulas can be written in the condensed form, like this, or even like this. In this form, you don't even see where there is a double bond, but you should be able to deduce it from the number of hydrogens attached to each carbon. Let's figure out where double bond is hidden in these pentene and butene formulas. Well, pentene means that we have to draw 5 carbons connected to each other, and then we see a clear anomaly over here with the number of hydrogens. So from the numbers that I see here, I can guess that there is a double bond right here. So this carbon has 2 hydrogens attached to it. This carbon over here has only 1 hydrogen that can be attached to it, and the rest of the carbons have hydrogens in all of their appropriate places. And over here, butene. Butene, 4 carbons. And once again, I'm looking for some anomaly with the number of hydrogens. I can see it right here. So there got to be double bond right here. That would explain why these 2 carbons only have 1 hydrogen attached to them. They don't have any more bonds. All bonds are occupied. And this carbon over here has 3 hydrogens, and this over here has 3 hydrogens as well. Alkynes are the unsaturated hydrocarbons that contain triple bonds between carbons. Once again, the smallest molecule of this kind must contain at least 2 carbons to have triple bond between them. Holding on to another carbon with a triple bond limits the amount of hydrogens these carbons will bind to. These carbons in the ethine have 4 bonds, all right, but each of them has only 1 electron to share with a hydrogen. Propyne over here has 3 carbons, and 2 of them are connected with the triple bond. Since each carbon has to form 4 bonds, this carbon can bond only to 1 hydrogen, and this one doesn't have any hydrogens attached to it. because all of its electrons are occupied by binding to the neighboring carbons. Just like alkanes and alkenes, alkynes have their own general formula. Ethyne, 2 carbons, 2 times 2 minus 2, 2 hydrogens. Propyne, 3 carbons, 3 times 2 minus 2, 4 hydrogens. Butyne, 4 carbons, 4 times 2 minus 2, 6 hydrogens. As always, prefix tells us the number of carbons in the molecule, and the ending "-ine" is specific for all alkynes. It tells us that this molecule has a triple bond between carbons somewhere in its structure. Here is pentyne, hexyne, heptyne, and so on. Here is my reminder that structural formulas might be written in the condensed form. Even if we write the condensed formula this way, we still mean that carbon is connected to another carbon directly, the way you see it written in the expanded structural formula. Supercondensed formulas sometimes are difficult to read, but with practice, your expertise will grow. Now, let's decipher this butyne and pentyne. Let's find a triple bond in those molecules. So butyne, 4 carbons, and on the first carbon we see 3 hydrogens. The second carbon has 2 hydrogens, and then we see empty carbon, carbon with no hydrogens, and the last one contains only 1 hydrogen. So triple bond is right here between these 2 carbons. It explains why this carbon over here doesn't have any hydrogens attached to it, because it is too busy holding on to neighboring carbons, and this carbon has only 1 electron ready to be bonded with the hydrogen. And now let's look at the pentyne. 5 carbons, and the first one has all 3 hydrogens in place. The second one has 2 hydrogens. Then we have 2 carbons that do not have any hydrogens attached. Most probably they are binded with triple bond. They are too busy holding on each other, so they don't have spare electrons to bind to hydrogens. And the last carbon is holding on 3 hydrogens. Now, pull out your reference tables and find this very useful table Q. It has the general name of each group of hydrocarbons. It has general formula of each group and examples of names and structural formulas. Now you know what I mean when I say very useful table. Few sample problems. Which formula represents alkanes? The one that obeys the alkane formula, CnH2n plus 2. Answer D looks like a ticket. Which compound is a saturated hydrocarbon? Answer C and D are not even hydrocarbons since they contain oxygen. So we should be choosing between A and B. Judging from the number of hydrogens, A is an alkene, which means it contains a double bond. It is an unsaturated compound. Answer B is perfect. It is an alkane, and as such, it is a saturated molecule, as all alkanes are. To better understand the term saturated and unsaturated compound in the context of organic chemistry, let's look at the examples of hydrocarbons propane, propene, and propyne. Propane is the molecule that contains the largest number of hydrogen atoms. The molecule of propane is filled up with hydrogen, saturated with hydrogen, up to its maximum capacity. Propene and propyne, due to double and triple bonds between carbons in their structure, contain less than maximum amount of hydrogen atoms. So they are said to be unsaturated organic molecules. Which condensed structural formula represents an unsaturated compound? We should be looking for the formula that contains double and triple bonds. This part of the molecule suggests the presence of the double bond. This is an unsaturated compound. Okay, second question. Which compound is an unsaturated hydrocarbon? The answer B obeys the alkene formula. Alkenes are unsaturated compounds. What is the total number of electrons shared between the carbon atoms of ethine? Well, 3 dashes. Each dash represents a pair of electrons. The answer is 6 electrons. Which molecule contains a triple covalent bond? The one that obeys the general formula of alkynes, CnH2n-2. Answer C2H2, ethine. Which formula represents an unsaturated hydrocarbon? Molecules A and D are not even hydrocarbons, and between B and C, C is clearly an unsaturated hydrocarbon since it has a double bond.